Hello everybody, getting ready to do lesson 9.4 part 2 pre-algebra math today, classwork. And then the classwork today for 9.4 part 2 is we got 20 points on your classwork sheet, so have your classwork sheet out in front of you. We got 0 points for your notebook, so that's not necessary. And then name, date, period. Students, put your name, date, period here. And then due date, onliners and homeschoolers. And we're going to go right into our next example here, which is example 3, ordering of real numbers. So using number line to order the numbers 4/3, negative 2.8, radical 3, and negative of radical 5 from least to greatest. So graph the numbers on a number line and read them from left to right. So here's our number line. So we start over here, negative 2.8. Then the negative of square root of 5 is about here. And then over here we have 4/3. And then over here we have square root of 3. Answer, from least to greatest, the numbers are negative 2.8, the negative of radical square root of 5, 4/3, and then square root of 3. Okay, so let's try one ourselves now. Using number line to order the numbers from least to greatest. That's it. Use the number line to order the numbers from least to greatest. Students, this is yours down here. We're going to do this one up here, our guided practice. So let's get on this one up here. So from least to greatest, we have firstly over here be negative 16/3 would be over here between 5.2, negative 5.2, and negative 5.4. And then we have the negative of radical 22, which would be about here. Then negative 4.6 would be about there. And then the negative of 3 times square root of 2 would be about there. And then from least to greatest, the numbers be negative 16/3, negative of square root 22, negative 4.6, and then the negative of 3 times square root of 2. That would be your listing there from least to greatest, and that's how they're presented up here on the number line. Okay, so on into our next example here, which would be example 4, using irrational numbers. Landmark buildings. Your class is visiting historical landmarks in Chicago. Outside the Washington block, here's our Washington block, you break up into 2 groups. Group A walks 800 miles east. So here's Group A walking 800 meters east, and 200 meters south to the Chicago building. Here's the Chicago building. Group B, which is over here, Group B, walks about 600 meters south. So Group B walks 600 meters south, and 200 meters east over here to the Rookery building. To the nearest 10 meters, how much further is Group A over here, from the Washington block than Group B? So we need to find the lengths here of these parts of these triangles. Okay, that's the question. Draw a diagram. We've had our diagram. Then use the Pythagorean theorem to find each distance from the Washington block. So we got Chicago building and we got the Rookery building here from the Washington block. So Group A over here, we got 800 squared plus 200 squared will equal our this distance here from the Chicago building to the Washington block. We take the square root of that, and we have the square root of 680,000. And then for the other group, Group B, Group A will be 825 meters for Group A. This is the length here of this Length here is 825 meters. And then group B would be 600 plus 200 squared will equal the square root of 400,000. That would be this distance here. So that comes out to being 632. So this is definitely shorter than this length over here. So the difference in distances would be 825 minus 632 would be 193. So to the nearest 10 meters, group A is about 190 meters farther from the Washington block than group B is. Okay, so let's get into a pendulum problem here. A period of a pendulum is the time that it takes the pendulum to swing from one side to the other and back. A pendulum's period P in seconds and its length in feet L are related by the equation period will equal 1.1 square root of L. And then this continues down here. And then we have the giant pendulum in a science museum of Virginia in Richmond is about 96 feet long, so there's our L. The giant pendulum in a new Detroit Science Center in Detroit is 40 feet long, so we have another L. We got two L's, 96 and 40. How much longer to the nearest second is the period of the pendulum in Richmond than the period of the pendulum in Detroit? That is your question. We found out our formula. We plug in values here from two different museums, and then how much longer is the the pendulum in Richmond than the pendulum in Detroit is the question. So to answer that, we're going to plug in, here's the length of your pendulum here, that is our L length, and we have two different L lengths. So now we can figure out the Richmond versus Detroit pendulum time in seconds. So Richmond would equal 1.1 times L, 1.1 times 96 would be 11. And then Detroit would be 1.1 times the square root of L, square root of 40 would be approximately equal to 7. So the difference in time would be 11 minus 7 would be 4 seconds. The period of the pendulum in Richmond is about 4 seconds longer than the period of the pendulum in Detroit. So there is your solution to this question. And that is your Pre-Algebra Part 2 lesson for today. Animated PowerPoint Math Video at AOL.com for questions or course materials. Thank you very much.